Well, that's the problem. The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe.
The Webb Telescope's recent findings are pushing the limits of what we thought we knew about space. It's uncovering unexpected things from the early universe, throwing a curveball at current scientific theories. Some believe what Webb's found might be a major challenge to our standard model of how the universe works. These discoveries could reshape our understanding of cosmology, offering new insights into the formation of galaxies, dark matter, and the Big Bang itself, the expanding universe. Astronomers recently made an unprecedented discovery, spotting a strange structure deep in the early universe. Trust me, if you could be in the room with me right now, you'd feel the excitement. Surrounding me are the brightest scientists, astrophysicists, and cosmologists, and they're all talking about how this new data is shaking up everything we thought we knew about the universe. It's a big deal. According to the standard model of cosmology, which we've been working with for years, the universe is about 13.8 billion years old, and it all started with the Big Bang. Since then, the universe has been expanding non-stop. But here's the thing. We all kind of know that 13.8 billion years figure isn't completely accurate. It's more of a rough estimate for the sake of discussion. So, just for now, let's stick with it for the video. Now, when scientists talk about the expansion of the universe, what they really mean is that massive objects like galaxies are moving farther away from each other. This means that the galaxies we see outside our own Milky Way are also moving away from us. It's like when you watch cars zooming down the highway. They appear to get smaller and move away from you the further they go. Same idea with galaxies, just on a much, much larger scale. To measure how far a galaxy is from us, scientists use something called cosmological redshift. Essentially, when light from a distant galaxy travels all the way to Earth, it gets stretched out, kind of like a rubber band being pulled. The farther away a galaxy is, the more its light is stretched, and we see that light shift toward the red end of the spectrum. In simple terms, the higher the redshift, the further away the galaxy is from us. It's like a cosmic ruler that tells us how far back in time we're looking when we observe those galaxies. The light from far-off galaxies takes a lot of time to travel across the vastness of space. So when we observe those galaxies, we're actually seeing them as they were in the past, not as they are now. The more distant the galaxy, the further back in time we're looking. It's like having a window into the past, but the further you look, the blurrier things get. And then, things got even more exciting when the James Webb Space Telescope came into the picture. Webb spots ancient galaxies. Light from distant galaxies stretches out into infrared wavelengths, which our eyes just can't pick up. The Hubble Space Telescope, for example, is limited to seeing light from ultraviolet to near infrared, so it has a tough time spotting galaxies that are beyond a certain distance. One of the furthest galaxies it found was GNZ11, which existed 13.4 billion years ago, just 400 million years after the Big Bang. That galaxy had a redshift of 10.95, which led scientists to believe that galaxies with a redshift higher than 11 were super rare, or maybe didn't even exist at all. But then, along came the James Webb Space Telescope. Unlike Hubble, Webb can see in infrared wavelengths, which is key because galaxies at redshifts 11 and higher emit light in that part of the spectrum. The old methods couldn't detect these galaxies, but Webb's ability to capture infrared light made it possible to detect them. So, the telescope launched, and as it started scanning the heavens, scientists began to see something pretty unexpected. A whole new picture of the universe started to take shape. Webb revealed dozens of galaxies that could potentially be among the earliest ever observed. These galaxies might even predate some of the earliest galaxies Hubble found. It was like getting a new pair of glasses that helped astronomers peer deeper into the universe's past. With these new findings, astronomers started searching for galaxies with very high redshifts. The higher the redshift, the further back in time we're seeing, meaning these galaxies could have formed much earlier than we originally thought. As the James Webb Space Telescope scanned the cosmos, NASA began detecting a surprising number of galaxies that could have been among the very first to form, just 200 to 300 million years after the Big Bang. This was huge, and it didn't stop there. Soon, Webb spotted what's now considered the oldest galaxy ever discovered, the Glass Z13 galaxy, with a redshift of 13.2. This galaxy formed only 300 million years after the Big Bang. That's incredibly early in the universe's history. This discovery was massive because it challenged what scientists thought they knew about the timeline of galaxy formation. Before this, astronomers believed galaxies took a bit longer to form, but finding so many galaxies from such an early time suggests they might have formed much sooner than we expected. According to the lead astronomer on this project from the University of Missouri, this finding gives us our first solid evidence that galaxies could have formed a lot earlier in the universe's history than previously thought. As if that wasn't enough, Webb soon made another mind-blowing discovery: a primordial galaxy that existed just 390 million years after the Big Bang. That's another galaxy popping up way earlier than expected. This new discovery caused quite a stir in the scientific community and was a big topic of discussion. Just when we thought things couldn't get more exciting, the James Webb Space Telescope dropped another discovery: hidden red object. Of course, everyone loves the images that come from Webb, and they're always curious about what the pictures are showing. But the real question everyone keeps asking is, what's new? What did you find that we didn't know before? Well, so far, the answers have been pretty mind-blowing. One of the biggest revelations is that the first galaxies didn't grow the way scientists expected them to. These early galaxies are completely different from what we thought we'd find. And to be honest, nobody really knows why their development doesn't match up with earlier predictions. And if that wasn't enough, the James Webb Telescope has just made another significant discovery that's got people talking. The European Consortium GTO team, which works with Webb, recently announced that they detected an extremely red object in the early universe that had been missed by previous surveys. This discovery was pretty impressive because the team found it while they were scanning for faint sources in new images from the telescope. Now, faint sources are important because Webb, with its powerful infrared capabilities, is designed to detect distant objects, but the light from these objects gets stretched out and weakened as it travels across the vastness of space. So, when light from distant galaxies reaches Webb, it's faint and appears redder due to the stretching, called redshift. Webb has the ability to see these faint, distant objects, but because the light is so faint, they tend to show up as dim and reddish in the telescope's images. The GTO team was specifically looking for these faint sources, which is no easy task. They were going through the new Webb images, hoping to spot these weak signals from deep in the universe. But instead of just finding expected faint sources, they stumbled upon something much more surprising: an extremely red object that had completely eluded previous surveys. The fact that they found something that had been missed before is huge, because it shows that Webb is revealing details about the universe that no one could catch with older technology. Scientists believe the mysterious red object discovered by the James Webb Space Telescope could be one of the most distant objects ever found. However, as with all things in space, there's a bit of a catch. Sometimes nearby objects can appear faint because they're obscured by dust clouds, but the team has ruled that out for this one. After studying it more closely, they found that the object looks extended, and importantly, it has stayed in the same position for an entire year. This was enough for them to confidently dismiss the idea that it's a brown dwarf, which would be a star-like object in our galaxy that doesn't shine as brightly as a full-fledged star. So, what exactly is this object? Well, scientists don't know for sure yet, but in a new research paper, they've come up with 3 possible explanations. The first suggestion was that it could be a dwarf galaxy with a lot of dust, located about 4 to 5 billion light-years away. But after more research, this theory became less likely. They also considered the idea that it might be a distant, dusty galaxy that formed just 1 to 2 billion years after the Big Bang, but this theory was ruled out as well. Now, the third explanation is where things get really interesting. It's one that's been gaining traction, and scientists are feeling more confident about it. According to this theory, the object could actually be a galaxy that shares some key traits with other small red galaxies recently discovered by the Webb Telescope. What's wild about this possibility is that this galaxy is positioned at a redshift of Zu-15, meaning it existed just 100 million years after the Big Bang. Basically, it's from the universe's infancy. If this theory is correct, this would mark the oldest and most distant galaxy ever observed, pushing back our understanding of galaxy formation by a significant amount. Finding a galaxy from just 100 million years after the Big Bang would be huge, as it gives us a glimpse into the very early stages of the universe when things were still in their infancy. The discovery would help us understand more about how galaxies formed, how they evolved, and what conditions were like in the very first moments after the Big Bang. And just when we thought we were starting to figure things out, the discoveries kept coming, forcing us to rethink everything we thought we knew. Rethinking the Big Bang. The discovery of these tiny red dot galaxies is seriously shaking up what we thought we knew about the universe. Scientists were already thrown off because these galaxies are much larger and brighter than current models had predicted. But now, with the discovery of an even more distant object, things are looking even more complicated. It's raising big questions about our standard understanding of cosmology, which has been the go-to model for how the universe works. What's really making things interesting is that scientists have found a galaxy dating back around 13 billion years, much earlier than what they expected. According to the conventional view, galaxies like this shouldn't have formed so early in the universe, not without the help of huge amounts of dark matter, which was supposed to play a key role in the formation of galaxies. But this new galaxy has more stars than our own Milky Way, and it formed just 800 million years after the Big Bang. That's crazy when you consider that our universe's 13.8 billion year timeline makes it clear that galaxies like this one were not supposed to exist yet, especially without dark matter to kickstart their formation. This discovery has left scientists scratching their heads. How is it possible that a galaxy could form so early, with so many stars, without dark matter setting the stage? Claudia Lagos, an associate professor of astronomy, put it pretty simply: massive galaxies popping up so early in the universe just doesn't make sense according to our current model of how things should have happened. Normally, dark matter is essential for holding early galaxies together, and those structures wouldn't have had enough time to form just 800 million years after the Big Bang. So, what's going on? To fully understand how this galaxy came to be so early, scientists are now thinking they might need to reconsider what happened before the Big Bang. And to be honest, that's where things get really speculative. Some theories are pretty out there, suggesting things like supernatural causes or a creator behind the universe's origins. Others are more grounded in physics, like the idea of a multiverse, essentially an infinite number of parallel universes, or cyclical models where the universe goes through cycles of birth, life, and rebirth. Then there's the fascinating theory put forward by Nobel Prize-winning physicist Roger Penrose. His theory suggests that there could have been another universe that existed before our Big Bang, which would explain how such massive galaxies could have formed so early. Now, Penrose's idea isn't exactly a favorite among cosmologists, but it's definitely sparked a lot of interest in the scientific community. For philosophers of science, it opens up an entirely new way of thinking about the universe, one that challenges traditional ideas of cause and effect. As if the mysteries of the early universe weren't enough, the James Webb Space Telescope also took things to the next level by spotting some truly explosive events. Detection of distant supernovae. The James Webb Space Telescope has really upped the game when it comes to exploring the vast, explosive wonders of the universe. One of its key achievements has been the detection of supernovae, those massive cosmic explosions that mark the death of stars. But what makes Webb's contribution so special is its ability to spot these supernovae in incredibly distant corners of space, even in the early universe. This is like turning back time and peering into an ancient, chaotic moment in the universe's history. The telescope uses its advanced infrared technology to capture light from galaxies and supernovae that are far, far away. Light that's been traveling through space for billions of years. It's as if the telescope is taking a snapshot of the universe when it was still a teenager, rather than the more grown-up version we see now. One of the standout moments in this journey was when the James Webb Space Telescope spotted a type Ia supernova called H-Europe. Located at a redshift of 1.78, this supernova is not only impressive because of its sheer distance, but because of its importance in measuring the universe's expansion rate. When you talk about the Hubble constant, the number that describes how fast the universe is stretching out, this discovery is a huge deal. It was also observed through something called gravitational lensing. This is where a massive galaxy cluster, like PLCK G165.7 plus 67.0, acts like a magnifying glass, bending light from the supernova and allowing astronomers to see multiple images of the same event. It's as if you're peering through a cosmic funhouse mirror, giving a clearer view of the explosion that occurred long before our time. But H-Europe isn't the only explosive story the telescope has unearthed. Webb has also managed to spot supernovae that date back to just 1.8 billion years after the Big Bang. That's crazy early, basically right after the universe had started to cool down and form the first galaxies. These ancient supernovae are like ancient artifacts, offering clues about how the universe evolved chemically. They tell us how the first stars created heavier elements, which later went on to form planets, stars, and life as we know it. Essentially, these supernovae are like the universe's chemical laboratories, mixing up the elements that would later shape everything in our galaxy. The telescope's ability to peer into these ancient explosions also has massive implications for cosmology, the study of the universe's origins, evolution, and eventual fate. By observing supernovae from billions of light years away, astronomers can test and tweak their models of how the universe works. A perfect example is how the discovery of supernova H-Europe is helping refine the measurement of the Hubble constant. There's been a lot of debate among scientists about the exact rate at which the universe is expanding. Different methods of measuring this expansion have yielded slightly different results, creating some tension in the cosmology community. H-Europe's discovery offers an independent way to measure that expansion, adding another piece to the puzzle and potentially helping resolve the ongoing debate. What makes these discoveries even more mind-blowing is that they're not just isolated events. They offer a deeper understanding of the universe's structure and history. For one, they help scientists figure out how galaxies have evolved over time. We now know that supernovae play a key role in that process, both by enriching the universe with new elements and by triggering the formation of new stars and galaxies. And if you thought supernovae were cool, just wait until you hear what the James Webb Space Telescope has uncovered about the early universe. Early universe insights. The James Webb Space Telescope has completely changed how we think about the early universe, especially when it comes to star formation and the growth of galaxies. In the past, scientists believed that star formation in the universe's infancy was a slow, gradual process, shaped largely by dark matter halos. However, what Webb has uncovered challenges that old view in some seriously groundbreaking ways. It's like we've been reading one chapter of the universe's story, and Webb has suddenly handed us the next one, filled with all kinds of surprises. One of the biggest revelations? Galaxies in the early universe were way more efficient at converting gas into stars than we ever thought possible. In today's universe, galaxies are only able to convert about 20% of their gas into stars. But according to the telescope's observations, early galaxies were working at a much higher rate, up to 80%. This is a huge leap, suggesting that star formation in those early days was a much more rapid and efficient process. If you think about it, that's a huge difference. It's like a factory that used to take years to build something, now being able to crank out products in a matter of months. This efficiency helps explain why massive galaxies could form so quickly in the early universe, long before the universe itself had cooled down from the Big Bang. But that's not all. One of the most exciting discoveries Webb made is the identification of what are being called red monster galaxies. These are ultra-massive galaxies that were already packing an enormous amount of mass, around 100 billion times that of our Sun, just within the first billion years after the Big Bang. That's seriously mind-boggling when you think about how young the universe was at the time. These galaxies don't fit into the traditional ideas of galactic evolution, which suggested that galaxies gradually built up their mass and structure over time through the slow accumulation of gas and star formation in dark matter halos. Instead, these red monsters suggest a more rapid, intense process of growth, turning everything we thought we knew about galactic development on its head. Another thing Webb revealed is how galaxies in the early universe were growing in a way that's very different from what we see today. In one particularly cool observation, the telescope found a galaxy just 700 million years after the Big Bang, showing a pattern of inside-out growth. Normally, we think of galaxies forming in their centers first, with stars gradually spreading outward. But in this case, the stars were forming faster on the outskirts of the galaxy rather than at the core. This type of galaxy formation was unexpected and has left scientists scratching their heads, wondering if early galaxies grew in ways that we're just beginning to understand. The rapid growth of galaxies in the early universe can be attributed to the rapid development of dark matter halos during this time. These halos created the perfect environment for galaxies to quickly form and grow. The intense gravitational pull from these halos helped galaxies draw in gas, and the efficiency of this process meant that star formation could happen much faster than in the more mature universe we see today. This period in the universe's history, just after the Big Bang, was one of rapid transformation. Galaxies were forming and evolving at an astonishing rate, and Webb's observations have made it clear that star formation was happening at a pace we never imagined. All of these findings point to one major takeaway. Galaxies in the early universe were not only forming quickly, but they were doing so in a much more efficient and intense manner than we thought possible. The ability of these early galaxies to convert gas into stars so rapidly suggests that the processes governing star formation were much more potent and accelerated in the universe's early years. Speaking of galaxies, one discovery in particular really stood out, showing us just how different the early universe was from what we know today. Firefly Sparkle. Galaxy one of the coolest discoveries by the telescope is the Firefly Sparkle galaxy, a galaxy so young and vibrant that it's almost like catching a snapshot of the universe when it was still figuring itself out. This galaxy is a perfect example of how star formation worked differently in the early universe, challenging a lot of what we thought we knew about how galaxies evolved. In the Firefly Sparkle galaxy, star formation is happening at a rate that completely defies what we see in modern galaxies. Normally, we expect galaxies to convert only a small fraction of their gas into stars, but in these ancient galaxies, star formation was much more efficient, like a factory that cranks out stars at an astonishing speed. The Firefly Sparkle, for instance, contains about 10 million stars, and it's clear that stars have been popping up there in big bursts. This efficiency suggests that something really exciting was going on in the early universe. Stars didn't just form slowly over time, but rather in a rapid, explosive manner. But what's really interesting is that the Firefly Sparkle galaxy wasn't just sitting there on its own, minding its business. It's surrounded by two smaller neighboring galaxies, and scientists believe that these interactions, maybe even some gravitational tug-of-war, could have triggered a recent starburst. That's when a galaxy suddenly starts forming a huge number of stars in a short amount of time. These interactions between galaxies, which might have caused bursts of star formation, were likely more common in the early universe, and the Firefly Sparkle galaxy is a great example of how galaxies could have grown rapidly by feeding off each other. The structure of the Firefly Sparkle galaxy is also something that gives us a lot of information about how galaxies evolved. Its star clusters, 10 of them in total, are arranged in a loose, diffused arc that stretches about 1,000 light-years. That's a pretty big galaxy, but what's even more fascinating is how the star clusters look. Some of them are blue, indicating they're home to younger stars, while others are red, meaning those stars are much older. This color difference isn't just pretty to look at, it actually tells scientists a lot about the galaxy's history. The younger blue stars have been forming more recently, while the red ones formed much earlier. This gives us a timeline of sorts for how the galaxy grew and evolved over time, showing us how star formation unfolded in different stages. What this tells us about the early universe is huge. The Firefly Sparkle galaxy is showing us how the building blocks of galaxies came together in those first few 100 million years after the Big Bang. Back then, the universe was a very different place. There was a lot of gas, and it hadn't yet settled into the more orderly structure we see today. That gas was highly efficient at forming stars, and galaxies were much more active and chaotic. In a way, the Firefly Sparkle galaxy is like a fossil from that time, showing us how stars and galaxies formed and grew so quickly. The discovery of the Firefly Sparkle galaxy also highlights just how much we've been able to learn about the universe's early stages, thanks to new technology like the James Webb Space Telescope. This galaxy, along with others like it, is helping scientists rewrite the history of how galaxies form and evolve. These findings make it clear that the early universe was far more dynamic and complex than we could have imagined. What we once thought was a slow, gradual process of galaxy growth is now looking much more like an explosive, fast-paced event, with galaxies colliding and triggering bursts of star formation in ways we never predicted. And this discovery isn't just interesting. It's actually forcing scientists to rethink how galaxies were born and how they grew so quickly. Rewriting galaxy formation theories. One of the most exciting revelations is how efficiently galaxies in the early universe turned gas into stars. This wasn't the slow, steady process scientists thought it would be. Instead, star formation was happening at a breakneck speed. Early galaxies were not only efficient at making stars, but they were also forming massive, full-fledged galaxies way earlier than expected. This discovery is seriously shaking up our ideas of how galaxies, including our own Milky Way, came into existence. Take the Firefly Sparkle galaxy, for example. This galaxy is a real game-changer. It's a galaxy from the early universe, only about 600 million years after the Big Bang, and it's already packed with around 10 million stars. It also has two smaller neighboring galaxies, which could be helping it grow, or maybe even merging with it in some way. The Firefly Sparkle is a perfect example of how galaxies didn't just form slowly and gradually, as many scientists once thought. Instead, the early universe was more like a cosmic race, with galaxies popping up quickly and efficiently. This galaxy, with its impressive collection of stars, gives us a front-row seat to the early stages of galaxy formation, showing us how the first galaxies were not as primitive as we once imagined. What makes the Firefly Sparkle so important is that it's part of a larger pattern of galaxies that are challenging the old-school view of galaxy formation. These galaxies are far more massive and mature than expected for their age, suggesting that star formation wasn't this slow, drawn-out process. Instead, it was happening in bursts, almost like flipping a switch and watching stars form rapidly. And it's not just about making stars quickly. These early galaxies are also showing signs of complex interactions. The fact that the Firefly Sparkle has two neighboring galaxies hints at how galaxies might have merged or interacted, speeding up their growth and fueling the creation of even more stars. This kind of discovery has huge implications for how we think about galaxy formation. The fact that these early galaxies were so big, so early, suggests that we need to rethink how galaxies form in the first place. Current models assume that galaxies grew slowly, starting as small pockets of gas and dust that gradually turned into larger galaxies over billions of years. But the Firefly Sparkle and similar galaxies are flipping that idea on its head, showing that massive galaxies could have formed much quicker than anyone thought. Researchers are now beginning to entertain the idea that new factors, like primordial black holes, could have played a part in speeding up galaxy formation. These black holes, which were believed to have formed soon after the Big Bang, might have acted as accelerators, pulling in matter and helping galaxies grow faster than we ever expected. The rapid formation of massive galaxies in the early universe is forcing scientists to rethink everything they thought they knew about cosmic evolution. Maybe the universe wasn't this calm, orderly place where galaxies gently grew over time. What do you think? Leave your thoughts in the comments below, and if you liked this video, don't forget to subscribe to our channel. See you in the next one.